Assalamualaikum and good morning to Dr. Fahmi and everyone. So we are from Consultant 9. We are going to explain the solution for the question from the previous class. So I am Farhana. I will start with the first question. So the first question asks for internal force at AB and BC. So the first step, I calculate the length of BC first and I got 1000 mm, and then I determine the theta at joint B and I got 36.87. And then to determine the internal force of the member AB and BC, the first thing first, I choose at joint B first because at joint B we have three force here, which is the external force, and then we have internal force of AB, and we have internal force of BC. And then I calculate using the equilibrium equation, and then I got FBC equals to 50 kilonewton in tension. When the result is in positive, so it is in tension. It means the force member pulls away. And then for the second step, I calculate for the internal force at AB and I got negative result, which is negative 40 kilonewton, which is in compression. Okay, for the second question, the question asks for shear force at joint A, B and C. So the first step, I calculate for the joint B. Why I calculate like this? It is because at joint B, it holds the member of BC and AB. So by calculate like this, I got to ensure that the joint B do have equilibrium there, because when we looking back from the previous question, we got the member at AB is in 40 kilonewton. So at the horizontal force at joint B, we also got 40 kilonewton, which is it is balanced. And then for the vertical, we got 30 kilonewton, and same goes at the diagram shows that the external force in a vertical at joint B is 30 kilonewtons. So the next one, for the joint C, for the horizontal shear force, I got 40 kilonewton to the right, and then for the vertical, I got 30 kilonewton downwards. So as for the last one, I got at joint A, for the shear force, it only have one direction, which is in a horizontal way, and I got 40 kilonewton. Why it is only one? Because at joint A we only have member force of AB, and from the previous answer we got FAB equals to 40 kilonewton in compression, which means when it is in compression means it push away the force to the left. So to make it balance and equilibrium, at joint A, the shear force must be must be opposite the force. So it should be to the right. The shear force should be to the right. So when it only have in horizontal force, so there's no vertical force here at joint A.
Assalamualaikum, my name is Nuzul Shadiki binti Dinael from Consultant Group 9, and I will explain about the bearing stress of the connected plate, which is the pressure on joint A and C. Bearing stress happens when a pin pushes against the plate or the rod surface. It measures how much pressure is acting between the pin and the material around the hole. The formula that we use to calculate bearing stress is sigma equal to P over T times T, where P is the load of the pin in Newton, T is the thickness of the plate in millimeters, and D is the pin diameter. At joint A, the force acting on the pin is 40 kilonewtons. The plate thickness is 10 millimeters and the pin diameter is 25 millimeters. Substituting into the formula, sigma equals to 40,000 divided by 10 times 25, which gives 160 megapascal. At joint C, the load is higher, 50 kilonewtons with the same plate thickness and pin diameter. So the calculation is 50,000 divided by 10 times 25, and we get 200 megapascals. For joint B, there is no plate or bracelet connection, only a pin connection, two rods. Therefore, there is no bearing stress on the plate, only shear stress on the pin itself. From this result, we can see that the highest bearing stress occurs at joint C because it carries the largest load.
Assalamualaikum and good morning. My name is Nur Amira binti Muhammad Fadil, and I will explain about the next question. We need to find the normal stress at the middle of the rod BC and at the flattened area, which is at the connection. So for this question, we know that the normal stress formula, which is force divided by area, and then because of the rod BC is circular in cross section, the area part should be pi divided by 4 multiplied with diameter power of 2. And then we know that the internal force BC is 50 kilonewtons, and then the rod also is circular with diameter of 20 millimeter, and then we insert all of that into the formula, and we got the final answer, which is 159.155 megapascal. Next, for the flattened area, we know that the flattened area is a flat part on a round object like pin or bolt. It is placed where the bolt or pin touch the plate in a connection. Even though it's called flattened area, the cross section is still circular because it connected using a bolt. So for this question, we use the same as before. The internal force of BC divided by area, the area of the bolt, and then we got the final answer is 101.86 megapascal.
My name is Bang Jiki. I will explain question number 4, shear stress of the pin at joint A, B, and C. In this question, I assume that this is the double shear at the connection place. So for the formula, shear stress equal to F per area, but because I assume it double shear, so every area need to times 2. So I get the area is this one, and then I can continue to find the pin A. First, remember AB equal to 40 kilonewton that I found on previous question. I get the shear stress using this formula, and for the pin B, it connect AB and BC, so it carry both axial force, but in perpendicular direction. So I need to do this first. After that, I can find this one. And for the pin C, first from BC only and equal to 50 kilonewton from the previous question. So it's just the same solution with the previous one.